Hi everyone, today I'm going to teach you a little bit about SQL. So it's going to be a full beginner's course on SQL and you're going to learn quite a few different things. First, I'm going to tell you a bit about what SQL is and where you might use it. And then I'm going to take you through how to create a database from scratch, define tables and also the data that will be stored in the tables. You'll also learn how to define relationships between tables, which will be useful later on when you're querying data across multiple tables. I'm also going to show you how to modify data, so you're going to learn how to insert data into the database and how to update and delete data that is stored in the database. I'll then take you through how to report on data, so different operations you can perform on the data, and also how to select different data and work with data across multiple tables. And I'm going to teach you a little bit about writing reusable queries. So these are queries that you can run with different parameters to save you writing the same query out multiple times, and it'll just mean that you can quickly run pieces of code that you use regularly and you'll be able to get the results a bit faster just because you've already written the code and you don't really need to mess around too much with it. And finally, I'm going to show you how to connect to a database from Excel. A lot of people who are in the position of learning SQL might be much more familiar and comfortable working in Excel, or they may have existing Excel processes. So I'm going to teach you how to pull data into Excel from your database. So what is SQL? SQL is basically a query language that will allow you to access and manipulate databases, and you may want to use it if you've got an application that's backed by a database, but you're wanting to get specific data out of it that's not available through the application, or you want to write some more complex reports. Data in the SQL database is relational, and it's stored in tables, which is basically sets of related data, and there are columns and rows. A row represents a record, and the different columns represent different fields of data like name, price, city, any sorts of things like that. And tables themselves can have relationships to each other too. So today I'm going to be using SQL Server Management Studio for writing my queries. And when you go to sign in, you'll enter your server name and choose your authentication method. So when you're wanting to create a database, you'll use the command create database and give your database a name. I'm going to call mine Miscoding SQL course. Then you can execute. You can click that button or hit F5. That will run and your database will be created and will be available to connect to. You can do that there, or there's also a command you can write. When you want to write a command to use a specific database, you'll write the command use and then the database name, or you can just select from that drop-down menu I just showed you. So if I go use Miss SQL Coding Course and execute, you can see that connection's changed to Miss SQL Coding Course. Now that we're connected to our database, I'm wanting to show you how to create a new table in the database, but first I'm going to explain what a primary key is. So basically, a primary key is very important in SQL database design because it helps you relate different tables together, and it's a column or set of columns in the table which is unique and not null, and this is typically is a single auto-incrementing int or identity column, and it's often called ID. It's best practice to include pretty much against every table because you never know what tables you're going to include in the future that might need a reference to the table that you're creating. It's a constraint on the table that uniquely identifies the row, and a table can only have one primary key, but the key can consist of one or more columns. I typically find that I'm just using one column, and it's just a integer, auto-incrementing integer, which I call ID. So now that you know what a primary key is, let's show you how to create one in a table. So to create a table, you're going to want to use the command create table, then the table's names. Then in the brackets, you're going to want to specify the column name, type, whether it's null, well, whether it allows nullables, so not null, or you can leave it blank if you do allow nulls. Primary key, which basically says that this ID column is a primary key, and identity is for auto-incrementing. I'm also going to have first name, last name, email, and enrolled on. The type for the first name and last name and email is envarchar, and in brackets you specify the max length. I'm going to make all of these not null so that when you're creating a record in the table, you have to specify each of these values. For enrolled on, I'm going to use the date type. You can use date time and date time too. They just have different levels of specificity. So this doesn't have any time attached to it. I'm also going to specify a default value. So I want the default to be the 18th of April 2022. So if someone tries to create a new student record and doesn't specify an enrolled on date, then it will basically use the default. So I've got first name, last name with a max length of 50 and email with a max length of 100. Now I'm going to want to go ahead and do the same thing for teacher. Once again, I'm going to create an ID column, and I just think that's best practice because you never know what you're going to need to link to in the future. I'm going to have that auto-incrementing as an ID, and the type will be int. I've got the first name, last name, and email once again. And then I can just execute that. And it will create the tables. Now if I go to Object Explorer and refresh the database server, then you can see my database has been created. And if I expand that further, I can see the tables that I've created, student and teacher. I can click on that to see the columns. I can see any keys and constraints that I might have on the table, along with any indexes and triggers. So that's useful if you want to sort of see a bit more about your tables. In order to create relationships between your tables, you're going to need to specify foreign keys against your table. And basically what these are is a column or set of columns in a table that contains the value of a primary key from a related or reference table. It is a constraint that prevents actions that would destroy links between tables, and typically you would name that something like student ID or teacher ID, so where the table name would be the table that you're referencing. So now I'm going to show you how to create a table with a foreign key constraint. What I'm going to have here is a table called course, and it's going to have a foreign key constraint on teacher because every course will have exactly one teacher, and a teacher may teach many courses. So what I'm doing here is I'm once again creating an ID, which is the primary key. I'm going to give the course a name. I'm also going to give the course a description. All of these things should be not null. Each course should also have a number of credits that it is that the student will receive for completing it. That will just allow us to perform some simple database operations later on and just show you a few different things. And that's going to be a small int type. You can learn more about types just by Googling them, and I will link some in the description below. Then there's going to be a foreign key constraint on teacher ID. I'm not requiring this to be not null because I know that in some cases it might be relevant that a course might not have a teacher assigned to it yet. So basically what I've done is foreign key references table name and the column that it is referencing, so the ID column of teacher, which was the primary key. So now I'm going to want to create a table that references both the course and the student. So I'm going to have two columns here and the ID column, which is the student ID column, which will be an integer, which is a foreign key that references the student table and the ID column. I'm going to make this not null because it wouldn't make sense to have no student for a course taken. And I'm going to do the same for course because once again, it wouldn't make sense to have a null course if a student's taking a course. And I'm going to have that one referencing the course table and the ID column. So now I've created all my tables. I'm going to want to insert some data into the table so I can start doing operations and reporting on the data in the tables. So I'm going to do an insert statement and I'll insert into the table name and then specify each column that I want to insert. You'll have to at least insert the ones that are not null and have that constraint on them. So first name, last name and email are not null for this table, so I'll have to insert those at least. I've also specified enrolled on, so I can actually specify a value for that differs from the default. And then I'll just specify the different values. You can insert one record at a time or you can insert multiple records at a time. First off, I'll just show you how to insert this single record. So if I execute that command, it'll insert that data into the database. So say I wanted to show you that it's going to use the default value. What I'll do is I'll just remove that enrolled on column and I'll just change the name because I'm wanting to insert a different record. So I'm inserting Joe Smith. And if I go ahead and execute that. Okay, so I've got this issue, error failed when converting date and or time from character string. So what I'm thinking is probably happening here is that I've probably specified a default in the incorrect date format, so it can't convert it to the date. So what I can do here is if I go to the student table and go to the different columns, I can see enrolled on and I can see a constraint for the default. If I go and script that to alter, so you can actually do this for lots of different types in the SQL database. You can right click on them and there should be the option to script to the window. If you do that, then you can edit it. So you can see I've done 2022-1804. So the 18 should actually be in the final place because it actually goes month, then day. So if I re-execute that, I'll have fixed up my default value. And when I run this, it should execute. Cool. So that's how you can insert a record with the default value. And next up, I'm going to show you how to insert multiple records into the database. So I just changed the names of the people that I'm wanting to insert. And all you need to do is add a comma after the brackets and copy the brackets down to the next line and just enter in whatever different values you want. So the first value is obviously relating to the first name column. The second value relates to the last name column, and the third value relates to the email column because that's what I've specified in my insert statement. So once again, it's insert into table name, then whatever column names you want to insert in the order that you want to insert them. And then you specify the values in the same order as your column name. And then when you insert, it should go ahead and insert them correctly. If I execute that, it will go ahead and insert all those values. So now I'm going to want to go ahead and do the same thing, but insert into teacher. I'm going to insert the name, first name, last name, and email once again. These are the only columns I have for the teacher, so I don't need to worry about the enrolled on because that was a student-specific field. So just add a few names here to represent the different teachers I have. You can note that I've changed the table name here, and I'm changing the values that I want to insert. And if I execute that, it inserts the 3 different columns, 3 different rows and 3 different columns. So now that we've got some data in our database, we can go ahead and select from our different tables. So the most basic select statement is select star from table name, and that will select basically all columns from the table. So you can see I'm selected all my teachers and all my students. You can see this ID gap between Jane and Joe, and that's because when I was having that enrolled on issue, it was auto-incrementing the identity, but it wasn't actually able to insert the data. So now that we have the primary keys for the teachers inserted, we can actually go ahead and show you how to insert into a table that has a relationship. So I'm going to show you how to insert into courses, and you can reference the ID from the teacher table so that you can specify which teacher you want teaching different courses. So I'm going to insert into course. I'm specifying that I want to insert a name, description, credits, and also the teacher ID. So I'll specify the different values for those. So I'll just give a name, a description, how many credits the student would earn. And then what I'm doing is I'm specifying a teacher ID. And basically what that's saying is that the teacher with ID 1 is the teacher for that course. So Marie Green is the teacher from this course. You can see they've done a select from teacher above just so I could see my teachers when I was going ahead and inserting, so that I could make sure that I could specify the appropriate teacher against each course. And that's just the foreign key constraint. And basically, if I try to delete from teacher and then reference by course, the database is going to stop me because it's that foreign key constraint stops me from breaking the relationships. And if the teacher's already referenced, it would break that relationship because they are teaching a course. So I'd have to go and either remove that teacher from teaching that course or delete that course before I could go ahead and delete the teacher. It's just a sort of safety mechanism on top of the database. So I can specify a different teacher that I want to teach a course. So for chemistry, biology, physics, I might have Ray Knight teaching a course. And so in that case, I'd be using the teacher ID 3 because that relates to the ID column of the teacher table, and that's what we've specified that our foreign key of teacher ID references. And it'll create a link that we can link the two tables together on later and perform more complex queries across both the tables to try and combine a bit of data and get some more complex reporting done. And now that I've specified all those courses, I can execute those statements and that will insert the different courses into the database table. Now I might do a select from student and a select from course. You actually don't need to specify the correct case for the table name. It's actually not case sensitive at all. And neither is select or from. A lot of SQL isn't case sensitive, so it's kind of good. The reason I'm selecting these is now I'm going to create the links between a student and a course. So basically the course that the student has taken, and from that later on we'll be able to get like the total credits that they've taken and whether they're taking any courses, stuff like that. So what you'll do is once again an insert into table name, then I want to specify the student ID and course ID. So the reason I've got this in a separate table is that I want students to be able to take many courses, and I also want a course to be able to take have many students taking it. If I'd specified a student ID or a course ID if I'd specified a course ID against the student table, then it would basically be implying that a student could only take one course. And if I'd specified a student ID against the course table, I'd be sort of implying that a course could only have one student, which we know would not make any sense whatsoever. So if you create this sort of table, it's kind of like a linking table. You can create a many-to-many relationship. So a course can have many students, a student can take many courses, and it's going to be great. So it allows you to sort of set up some more complex relationships in your database. So you can see I've got student number 5, which is John Doe. He's taking courses 1, 4, 7, and 8. So statistics, algebra, physics, and computer science. And I've got some other students taking other courses. If I run that again, then I'm going to get those courses taken inserted. Now that I've populated all the tables that I want to with data, I'm going to show you a bit more about selecting from the tables. So I'm going to show you a select from student, and I'm going to show you how to use the where clause, which will allow you to filter out data from the table. So when it matches the condition in the where clause, that data will be returned. So I'm looking for someone where their first name is equal to Joe and their last name is equal to Smith in this case. So you can see that only one result is returned, as that's the only row that matches the condition that I've set in this where clause. You can also use or instead of and if you wanted to match multiple things, or you can use in if you want to select multiple rows as well, and I'll show you that a bit later on. So now I'm going to show you a bit of an update statement. When you do an update statement, you should always have a where clause, otherwise you're going to update all the rows basically. So I did my select first just to make sure I had the right where clause, and now I'm going ahead and updating that student to have a different enrolled on date. So you can see that I've set their enrolled on date to be the 20th of April, whereas it was previously the 18th of April. So if I select star from student, then you can see that Joe Smith has that date updated to the 20th of April because I've specified that I want to update that student. Yeah, the select was useful in advance because it allowed me to see which student I'd be updating and make sure I had the right where clause. So now I'm showing you a bit about aliases. So aliases basically allow you to refer to the table by a different name. So I can specify that I want to select the name column from course, but I'm only having to put c.name instead of course.name. And I can also specify what I actually want that column to be in the table when I get the results table. So you can see I've got course name and course description, even though the column names are name and description. And if I want to have a space in there, I can just make that a string with the single quote operator. So what if you want to select data across multiple tables? For example, you might want to select the course name and the course description and the students that are taking that, so the student's first name and last name. So if you wanted to do that, you're going to need to join the tables together. So join is just a way of combining rows from two or more tables, and it's based on the related column, which is the foreign key between them. There are a few different types of joins. One of the more common ones is an inner join, and basically what an inner join is where there are matching values in both tables. So it basically takes the intersection between the tables. It returns the smallest result set of any of the join types, as it won't include rows where there are no links in the join table. So now that we've got a vague idea of what an inner join is, let's see one in practice. So what I'm going to want to do is I'm going to want to inner join teacher. So I'll use that keyword inner join, specify the table name that I want to join, and then I'll do the alias, so as t, and I'll say on, which basically means your join condition, and I'll specify that I want the teacher ID to equal the t.id, so that ID from the teacher table, as that's our foreign key relationship that we have. And you can see that I'm only selecting the course name and description at the moment, so I want to add the teacher's email address to the select statement, and I'll show you that the different emails for the different courses. So if I wanted to say email my stats teacher, I could. Another commonly used type of join is the left join. It's the type of join where all the results in the left table, which is the first table you're joining, are returned, and only the matching records from the right table are returned. When there is no matching record in the right table, null will be shown against the right table columns. So let's show you an example of this. We're going to want to insert some fresh data into the teacher table so that we can show you that when you have a teacher and they don't have a course associated with them, then you will be able to see them with a left join versus not being able to see them with an inner join. So I'm inserting a new teacher, Joy Samming, with the first name Joy, the last name Samming, and the email jsa@example.com. So that's what this insert into teacher statement is doing. So once I've done that, I can see I've got my new teacher in that table. And if I do my inner join as before, then I'm not going to see Joy Samming in the list, as I haven't created a link to a course for her. So there's no jsa@example.com in the email list. So now I'm going to show you how to do a left join. So basically what I'm doing here is I'm going to select the course name, the course description, and the teacher's email once again. Actually, I'll do the first and last name. And then I'm going to select that from teacher. So that's going to be the left or the first table that I join. Then I'm going to left outer join course, which basically means that any teachers will show up even if they don't have an associated course because they're in the left table. So everything in the left table will be returned in the results set. So if I execute that, you can see that there's no course, so null values for Joy Samming, but the Joy Samming is still returned as a result. And that's just because it's the left table and I'm doing a left outer join. We also have a right join. So a right join is very much like a left join in that it's a type of join where all the results in the right table or the second table that you join are returned and only the matching records from the left table are returned. Where there is no matching tables in the left table, null will be shown against the left table columns. So it's basically the opposite of the left join, but I tend to write most of my queries that I use the left join just for a matter of consistency. I find it makes it more readable for me personally, but it's just a matter of preference there. So now I'm going to show you a right join. So what I'm going to do is I'm just going to swap the order of the tables that I'm joining. So I'm going to join, select from course and join to teacher, making teacher the right table and course the left table. So if I go and do a select on that, you can see that I've got null in the course name, but if I change to left, because the teacher is the right table now, and there's no courses without a teacher link, I'm not getting any nulls showing up there. So that's how they differ a bit. So those are the main types of joins, but now I'm going to show you how to use the union, which will also allow you to select data from multiple tables. So say you want to select all the emails from teachers and students, you can do a union to do that. So you can select email from teacher and union that to select email from student, and basically it'll combine all the results into one result set. So you can see this would be useful if I wanted to build up a mailing list to contact all my people on campus. And I'm just adding an extra column. You can basically add whatever you want as an extra column that will identify students and teachers by their roles. I had to put that role in quote, as role is a keyword in SQL. So there you go, you can see which ones are students and which ones are teachers. Now I'm going to show you a little bit about wildcards. So if I select star from student, you can see all my students. I'll use that as a base for my future selects. And I'm going to show you wildcards. So when I do select star from student where first name is like something, I can use a wildcard. The percentage wildcard just matches anything, and so it selected anything with the first name starting with J. Now if I do a select star from where enrolled on like 2022-04 and then any numbers, it will basically select any student enrolled in April, because I'm allowing for any numbers with those square brackets because I've given a range of 0 to 9 there. And you can see that any student with those dates is selected. So now I'm doing a select star from email where from student where email is like %@example.com. Basically they'll allow me to have any email selected because it will pick up anything that the email started with, but when I add that B, it only picks up anyone with the B right before the @ so it will match anything up to that B@example.com. Now I'm doing another one where I can specify that I want it to be a 4-character name with O or A as the middle letter. So you can sort of see they've got Jane and John selected there, but Joe wasn't selected because I'm expecting 2 more characters using those underscores. Basically the square brackets will allow you to select anything that's in it. So this one's going to select anything where it's J and the second letter is anything from A to E. So it's picking up B and D, but not S. Now I'm going to do another select. And I'm doing a not B or D. So this one's going to select JS@example.com because that little caret character means not. So it's basically using wildcards. Now I'm going to show you how to alter a table. So I'm going to alter the table student to add a column. So I'm wanting to add a column called phone. So that's going to be the student's phone number. And I'm going to allow that to be null. So I'm not specifying the not null constraint. And then I'm going to select star from student to show you what the column will look like once it's created. I'm creating it as a nvarchar 20, which is basically a string of 20 characters long that can be null. Cool. So when I select star from student, all of them have null phone numbers, and that's to be expected because I haven't specified a default value. I haven't updated any of the students' values, and I didn't specify that not null constraint. So now I'm going to show you joining multiple tables. So I'm going to select the students and their courses taken, and to do that I'm going to need to join onto that course taken table, and then from there I'm going to have to join one step further onto the course table so I could get the course names and the student names. This is a many-to-many relationship, and that's why I need that extra linking table there. So if I do the select statement, then you can see that I've got multiple students showing up because the students are taking multiple courses, and the courses can also show up multiple times if multiple students are taking those courses. I'm showing you another way of joining the multiple tables. So now I'm going to select star from student and left outer join course taken. Basically what this is going to do is it's going to allow me to sort of see any students that aren't taking a course, but it will also still show me any students that are taking a course. If I wanted to only see students that weren't taking a course, then I could select, I could add a where condition where the course ID is null, but I'm just going to show you what the full result set would look like without any filtering. So I've got left outer join to course taken, and you can see that Sarah Beetle and Rob Brown are not taking any courses. They've got null values against all the course columns. So now I'm going to show you what might happen if you have a course not being taken. So what I'm going to do is I'm going to do a right join on course because I want to see any courses that aren't taken, and I just want to also see the students as well that are taking courses, but I'll also show any results for courses not taken. So if I do the select here, you can see that I've got no students taking that insanely hard course. You can still see that there are multiple courses listed where multiple students are taking them. But yeah, for any courses where they're not being taken, it's null. This leads nicely into the full join. So the full join basically would allow you to get all of the results for students and all of the results from courses, even if there is either no courses taken by a student or no students taking a course. So basically it is a type of join that returns all the results that meet the where clause condition from both table 1 and table 2. As these are not constrained on matching records in both tables, they can potentially return quite large sets of data, so you should be quite careful about using it. And in practice, it's not used that often. I think I've probably used it maybe once or twice, but if you did want to see all of that data as a whole, you might use a full join. Now that we know about the full outer join, let's go ahead and see that in action. So basically what I'm going to do here is I'm going to select star from student, and then I'm going to do a full outer join to course taken, and I'm going to use that foreign key of course taken student ID and join that on the student's ID. And then I'm going to do another full outer join to course. And I'm going to be joining that on the course ID of the course taken table and the ID of the course table. So if I run that statement, you're going to see nulls against course, where the student's taking absolutely no courses. And you're also going to see nulls against student, where there is no students taking the course. I'm also wanting to show you a self-join. So self-joins I also don't commonly use, but they can be used. And in this case, I'm going to show you how you might select a student's classmates using a self-join. So you'll do select star from student, and you're going to give that an alias, and then you're doing a comma to do the self-join, and you specify the table once again, which is student, and give another alias. And what I'm wanting to do is specify where SID is not equal to S2ID.ID, so I don't pick up the same student. And I'm also going to want to check where the first name of the student, the first table that I'm joining is Miss, and the last name of that first table I'm joining is Coding. And I'm going to want to check that they have matching enrolled on dates. So basically it's going to pick up any students that are enrolled at the same time as Miss Coding, but aren't Miss Coding. And so that would be useful for if I wanted to find out the classmates of Miss Coding. So I'm going to just select the first name and last name of the student 2. And that's just because it's good to select specifically what you're interested in, because if you're over-selecting data, it can be bad for performance, particularly when you're sending data to and from the server, so when you're connecting to the database. So yeah, I've got all the classmates for Miss Coding. Those are ones that enrolled at the same time as her. So if I do a select star from student, I'll just verify that my query is working correctly. I can show you. So I can see that Miss Coding has these other students, John Doe, Sarah Beetle, and Rob Brown, all enrolled on the same date as her. And those are the ones that are returned by my self-join. So sometimes you might want to select the top X results from the table. And that would be if you, for example, want to see which courses will give you the most credits or which would give you the least credits. So if you're ordering by credits ascending, it will sort from 0 through to the highest credits and select the top 5. And if you select top 5 star from course order by credits descending, it'll give you the highest credits down to the lowest credits, but we want to only select the top 5, so it will do that. So if I run that statement, what you're going to see is the courses that will give you the least credits and the courses that will give you the most credits. I'm also going to want to show you the min and max function, so you can use that if you just want to see what the minimum credits you can get from a course is. So you can use that min function on any number column, and you can also use the max function on any number column, and that will give you the max credits. So if I run that, you can see min credits of 0 and max credits of 30. That can be used to perform more complex reporting later on when you learn more. I may also want to see what distinct credits there are, so the range of credits. So I could do that. This distinct one will basically give me anything non-repeating, so 0, 15, 30, even though there may be multiple courses with 30 credits. It only shows it once. So now I'm going to want to go ahead and show you how to update a student. So I'm going to update the student's phone number in this case. So I'm updating a student and setting their phone to be equal to a value. When you're doing an update, you're going to want to make sure that you've got the where clause correct. If you don't have the where clause correct, then you're going to update the wrong data, and it's going to be quite confusing later on when you're going to build reports if you're not got the data that you're expecting just because you've updated the wrong student. So yeah, usually when I'm going to perform an update, I'll actually do a select with the relevant where statement just to make sure I'm updating the correct student and have the where statement correct before I perform the update. Because once you've done the update, if you don't notice, it could be ages and very challenging before you notice. And I'm also just going to show you how you can specify selecting something that is either not null or is null. So the first statement will select students with where the phone number is not null. And the second statement there will select students where the phone number is null. So only Sarah Beetle should be selected in the first one, and that's because I've just updated her phone number. But then in the second one, all the remaining students are selected except for Sarah Beetle because I haven't updated their phone numbers and they were null as a default. You can also use the count function, which will allow you to count the number of rows matching the criteria. So I might want to check how many students had an enrolled on date that was not equal to the 18th of April, which is the default. So that basically means I've had a result specified or updated for them. So there's two students that match that criteria. Now I want to show you a couple more functions that may be useful to you with building reports. So I'm going to show you the average function, which will get the average for a numeric column. So if I wanted the average credits, I could use average credits from course, and that's what the result is, number 23. If I wanted to get the sum of total credits available, then I could just sum the credits from the course table. I can give that alias if I want, so that in the results set it's showing what that number actually represents. So you can see I've got this total available credits of 210, which is a max amount of credits available to students if they took all courses. Now I'm going to show you grouping, which is one of the more complex topics I'm going to cover today. So if you don't understand it, it's all right, you can still get by. So what you can do with grouping is you can actually perform aggregate functions across different tables. So if I wanted to get the number of students enrolled in any particular course, I could get the count of course taken student IDs and select student name. So what I'm going to want to do here is I'm going to want to left outer join course taken because I want to show where there's no students taking a course as well. And I'm joining, of course, on the course ID of course taken and the course tables ID, as that's what the foreign key constraint is on. Now I'm grouping by the course ID, and that's just making sure that I've got everything grouped by that course. And then the name, I need the name because I want to select the name. You don't need to select group by things which you're going to perform an aggregate function such as count on. But if you are not performing an aggregate function, you do need to specify it in the group by statement or you can't select it. So you can see that I've got the different counts of students enrolled. So for Insanely Hard, there's 0 students enrolled. For Statistics, there's 3. And for biology, chemistry, algebra, geometry, calculus, there's 1. And for physics and computer science, there's 2. So you can verify that your grouping's working correctly if you just do a simple select. I forgot the alias here. If you do a simple select, you can sort of just check that you've got the right number. So we've got 3 for statistics, 1 for calculus, geometry, algebra, and so on. So we know that our results are correct. And if we looked at the students taking insanely hard, it would be null because there's 0 students taking it. So yeah, that's how the group by works. It is quite a complex sort of thing to get your head around, and just using it over time, you'll get used to it. But you can do many complex queries without it, so don't be too concerned if you didn't understand that. I'm going to do another group by, just because I think they are quite complex. And I also want to show you a having statement, which basically is kind of like the where clause for grouping. That's how I like to think of it. So I'm going to select the student name and the count of student IDs, so the number of students enrolled from course. I'm going to left outer join course taken on the course ID, as that's the foreign key constraint. Then I'm going to go ahead and group by the course ID and the name. Once again, that's just because I want to group by something unique, and I want to specify that it's having a count of students enrolled greater than equal to 2. So this is only going to return those courses taken which have more students enrolled than greater than or equal to students enrolled of 2. So it's not returning any classes where there's only 1 or 0 students enrolled. So you can see how the having acts as a where statement for where you've got a grouping. Now I'm going to want to show you how to add an order by to your grouping. So basically that will allow you to group by, when you're grouping by, to order by something. So I'm going to do very similar once again, but I'm going to be grouping by the students, and I'm going to be summing their total course credits, so that I can get an idea of who's got the most credits. So maybe the person who's performed the best and managed to complete the most courses. So I'm going to select the first and last name and the sum of credits. From student, I'm going to left outer join course taken, because I want to be able to get a sum of 0, and that's what that is null function is doing. If the sum of credits is null, then it will specify that the value should be 0. So it checks if the value is null, and if it is, then that second value is what the actual output value is. So if it's null, it will be outputting 0. Left outer joining courses, once again, I want to include any courses. I want to include any students that don't have a course. I'm grouping by student ID, and I need to include the first and last name, as that's what I'm going to be selecting. And I'm going to order by the sum of credits that they've achieved. The credits don't need to be included in the group by statement once again, because they're included in that aggregate function, which is sum. I'm going to order that by descending, so I get the highest first. So you can see Joe Smith and John Doe have completed the total credits of 105, Miss Coding of 90, Jane Berry of 30, and Rob and Sarah Beetle are of 0. If I remove that as null statement, I'm just going to show you what would show if I didn't have that replacing the null to 0. So you can see that Rob Brown and Sarah Beetle have null in total credits, just because they it's because they have taken no courses, they actually don't have any value against that sum of credits. So there you go. If I remove that order by descending, you can get it ordered by ascending. But yeah, I've got that descending once again, and you can see that the values are 0 because I've got that is null. Next, I'm going to want to take you a bit deeper into how you can create reusable SQL statements. So that's going to be really useful for if you've got the same sort of query that you're running again and again to get a certain report out that you need on a regular basis. So often when you're writing reusable code, you're going to have something called a variable, and a variable stores a value that can then be referred to elsewhere in the SQL statements, and it will have a type and a value. So it might be an integer, which is basically a number type. It might be an varchar, which is basically any characters inside the quotation marks. And then it will also have a value. So maybe I've got an integer and I want to select any courses with credits over 15. I could have my variable set to 15 and I could reuse that code again and again, or I could create some reusable code later on which passes in a variable value and then uses that to perform different actions based on the variable value. So the benefit of using a variable is they can be passed into stored procedures or functions and used to achieve different outcomes. It also means if the value changes and the variable was used in multiple places, we only need to make the change in one place where the variable is set, rather than going through all our different SQL statements to try and find where I've set this value manually. So yeah, it can save some time in that aspect and also reduce some errors and make your life a bit easier. So now that I've shown you what a variable is, I'm going to show you how to declare one. You'll go declare, then variable name prefixed by an @ and then you can specify the variable type. You can actually select into a variable, so I'm going to show you how to do that now. Basically what I'm going to want to do is select the student that's taken the most courses. So I'm going to select from course taken, and I'm going to group by the student ID, as that's what I'm wanting to select. So it needs to be in my select statement, in my group by statement. And I'm going to order by the count of courses taken, so the course taken ID. That's going to give me the student that's taken the most courses. If there's multiple students that have taken the same number of courses, it's just going to return one of them. If I wanted to get a specific one, I could, like maybe alphabetically, I could order alphabetically as well, but in this case I'm not going to do that. So you can actually select the value of the variable by just doing a select at variable name. So I've got select at student ID, and this is just me showing you the actual results from the query if I hadn't selected into the variable, and that's just going to help you sort of verify that you're getting the right data out. So I find that quite useful when I'm writing SQL, is just to compare with what the full result set would be. So we've got student ID of 4, and we can see they've taken 4 courses, which is the max that any student has taken. So that result was valid. So now I'm going to explain a bit about if-else statements. So if-else statements are basically where you have an if statement and it's followed by a condition. And if this condition is true, it leads to the statements inside the if statement being executed. And if the condition evaluated to false, the statements inside the else statement are executed instead. So this is useful when you conditionally want to execute statements, and I'm going to show you an example of that in a minute. But basically it will allow you to have quite flexible SQL statements and reports, and do a bit more complex things. So basically what I want to achieve here is I want to output a message if the student exists by using their email or not. So maybe if, for example, I wanted to check that a student was enrolling, when they're enrolling, that they're not using an email that already exists, then I can check for an email using an if statement. So I'm going to and output a message. So I'm declaring my email. It's going to be in varchar 100, and I can set the email just by going set variable name equals to the value. So in this case, I'm going to use jb@example.com. And if the email exists, then I'm going to output that there is a student existing with that email. And otherwise, I'm going to output that there's no student existing with that email. So I'm just doing a select top one email from student where email equals my variable value. And if that exists, I'm going to do the begin and end. I like to include those even though they're not 100% necessary unless you've got multi-line if statements, just because I find it makes it more clear in terms of readability, and if you add more statements later, you don't need to go and re-add them. So yeah, inside the begin and end is the SQL statements that will be executed if the if statement condition is true, which currently it would be because we do see a person in the list with that email address. So if there is a student with that email address, it'll select student exists, and if there isn't, it'll select no student exists. So if I go ahead and run that, it should output, it outputs student exists. But if I go ahead and change the email address to something that doesn't exist, then it'll output no student exists. So it's just an example of how an if statement works. So that's really useful in Reusable SQL, and I'm going to teach you a bit more about Reusable SQL right now. So basically, when you're writing Reusable SQL, you'll be writing it in either a function or a stored proc, and they can be just used to create reusable SQL statements out of common queries, and they commonly have parameters passed to them so that they can perform different functions depending on or different actions depending on what is actually passed to them. So a parameter is a value that the user specifies when calling a function or stored procedure, and it affects the result by performing statements with the context of the parameter. So I'm going to show you about that in a minute, but first I'm going to explain a bit more about functions. So functions are basically reusable SQL statements, and they must return a value and can only have input parameters. So they're a bit more rigid than stored procs, which I'll explain a bit more detail later on. They also cannot call any stored procs and can only contain select statements. So functions can be used in SQL statements such as select, where, and having. And functions are actually, you remember if you think back to when we were doing grouping, we had the sum, the count, the average, the min-max. Those were all functions that we could use. So that is exactly what a function is. It's basically something that performs a bit of logic for us. And we can reuse it again and again without having to implement the actual detail every time. They can also be used in joins when they have a return result of a table, but that's a bit less commonly done and is also a bit outside the scope of this course. Now I'm going to go ahead and show you how to write a function. So basically you're going to write create function, and then you'll give the function its name. So I'm just calling this one hello world func. Then you'll create some brackets, and inside those will be any parameters. This one has none. And you have to specify the return type. A function always has a return type, and this one's going to return in varchar of 20. And then you specify what statements are inside this function. So this one's just going to return hello world. And that's it. If I execute that statement there, then it will create that function. And if I looked at Object Explorer, it would be available there. Now I'm going to show you how to call the function. So you just go select dbo.helloworldfunc, and that will just call that function there by using those little brackets there and select as outputting it. If I wanted it to go to messages, I could use a print instead of a select. So we also need to learn a bit more about stored procs. So stored procs are a bit more flexible than functions because they can optionally return a value, and they can also have both input and output parameters. And they can also call functions and can contain any CRUD operations. They can create data, they can read data, they can update data, and they can delete data. Whereas inside a function, you can only select data. Stored procs can't be used in where, having, or select SQL statements though, which functions can be, because remember we've talked about the count function, the sum function, things like that. So stored procs can't be used in the same way as that. So now we know what a stored proc is. Let's go ahead and create one. So you'll use that create keyword and specify that you're creating a procedure and the procedure's name. So we're going to call this one Hello World Procedure. Then you'd specify any parameters, but I'm not going to have any for this, and any return, but I'm not going to have any once again. And then the statements you want to execute when your procedure's called. In this case, I'm just going to call that Hello World function just to show that you can call a function from inside a procedure. And so now that I've got my procedure, I'm going to show you how to go ahead and call it. You use the exec statement, which executes your procedure, and then the procedure's name. So if I execute that, it selects Hello World because that's what was happening inside my stored proc. So now I'm going to go ahead and give you a more practical example of how you'd create some reusable SQL statements using a stored proc. So I'm going to create a procedure that gets the courses for a given teacher, and it's going to take parameters of the first name of the teacher and the last name of the teacher, and then depending on that, it will return the courses that match with that teacher. So what I'm going to do is I'm just going to select the courses, so all the columns from courses. So C.star means all the columns from the table with alias C, which is the course table. Then I'm going to inner join the teacher on the course's teacher ID, as that's the foreign key constraint, and I'm just going to do a where check, and I'm going to check that my first name and last name match the first and last name passed to the get teachers course stored proc. And if they match, then any courses that match for those teachers will be returned. And so that's how you can create a usable sort of statement that can be reused to get different outputs depending on the input parameters provided. So now that I've created that, I'm going to go ahead and show you how to actually call that. So I'm just going to do a select star from teachers. And you can see all the teachers there. And then I'm going to execute my get teachers courses stored proc. And I'm going to pass in the first name and the last name. So if I specify first name as Marie, last name is Green, then I should get any courses that Marie Green is teaching. So go ahead and execute that. I'll get all the courses that she's teaching. I can go ahead and do the same thing for all the other teachers as well. So we've got Carson Jr. So if I execute for him, I'll get any courses he's teaching, which is just the insanely hard course. If I execute that statement again for all my other teachers, so Ray Knight, I get any courses he's teaching, which is those 4 sciencey courses. And I'm just going to check what other teachers. Okay, yeah, I had Joy Samming. So if I check for Joy Samming, I believe she doesn't teach any courses because I inserted her to just show that you didn't necessarily have to have a teacher that was teaching courses. I'm also going to show you if I had a completely made up teacher name, so that it would show basically the same results as Joy Samming, purely because there's no courses for that fake teacher. So now that we've done that, I can show you how to drop functions and store procs if you're done using them and you don't think you're going to use them again. Just to clear up your database, you might want to drop them. So to drop a function, you just use the keyword drop function, function name. And to drop the procedure, you use the keyword drop procedure, procedure name. And those will drop those procedures and they will no longer be visible in Object Explorer. So if I go to programmability, you can sort of see what functions and stored procs you already have. So you can see I've got my Hello World procedure there. And I've got my Hello World function there. If I run this command though, and go back and refresh, and go back to programmability so that I can see my stored procs and functions. You can see that I no longer have my Hello World procedure, and I no longer have my Hello World function either. So those have been removed from the database because I've dropped them. By now you know how to do most things in SQL, but one thing I haven't taught you yet is how to delete data. It's much like updating data, where you're going to want to make sure that you've got a where clause, and I'm just doing a select count of students before delete and after the delete, so you can see that this is actually working. But anyway, basically it's much like the update. You'll do delete from whatever table name, and then you'll specify your where clause. The where clause is very important. If you do not specify your where clause correctly, you're going to end up in trouble because you're going to delete like the whole table, or you may end up deleting the whole table. So check with the select first. But anyway, what I'm doing here is I'm selecting any student where their ID is not in, and then it basically is a list of student IDs and that have a course taken. So basically I'm deleting any students that have not taken a course, and then I'll select the count after. So there were 2 students that didn't have hadn't taken a course previously, and they've now been deleted. Another thing that might be useful for you to do is to learn how to back up your database. So basically that's useful if you're wanting to transfer your database somewhere, or maybe you're wanting to come back to it later or move it to another computer. So you can back it up to a specific file location. So you specify to disk and then specify the file location you want to back it up to. And you also need to obviously specify the database name of the database that you want to back up. So this is backing up my miscoding SQL course database to the location C drive backups miscoding SQL course.bak. Then I'm just going to show you how to drop a database. So if you're no longer using a database, you can go ahead and drop that database. So the command you use is drop database, but you need to make sure you're not using that database when you drop it. So you want to go use master or something like that. And then from there you can use drop database name, which is miscoding SQL course in this case. If there are anything still using that database, it's going to tell you that there's a connection active, and then you're going to need to go and kill that connection before you can go ahead and drop the database. So you can see that I'm getting this error, cannot drop database Miss SQL coding course because it's currently in use. That's the error I was talking about earlier. So to get rid of those, you can execute this stored proc sp who, and what you're looking for is a database name which matches Miss Coding SQL course. So I can see that one there with the SPID of 61. So what I can do is I can actually do a kill on that 61, and that's going to kill the connection there. And I'm going to be able to drop my database after killing that connection. So once I've done that kill, I can once again call my drop database, and look, it's working and successfully been dropped. If I were to go to the drop down menu to connect to the database, it wouldn't be available because it's been dropped from the database server. But if you did want your database back again, you can actually restore from the backup that we created just previously. So you'll do restore database Miss Coding SQL course from disk, and then you'll specify the location, which was once again C drive, backups, and then Miss Coding SQL course.bak. And if we run that, then it's just going to get my whole database that I'd backed up back. If you're working and think you might make a mistake, you might want to use some snapshots, but I haven't included that in this course today. You could also use backups, but they're a bit more heavyweight. So you can see I've now got my Miss Coding SQL course database back, so I can select from it and do any actions I previously could do on my database. It's fully available again with the exact same data from when I backed it up. In production systems, you'd want to be regularly backing it up to ensure that if there's any failures of your drives, you're not going to lose data. Now, a lot of you might want to work with data in Excel because you might be more familiar with that. To do that, you just go to this data tab, get data, and you want to make sure you're getting it from the SQL database. It's going to pop up a SQL Server database connection screen where you can specify the server and the database that you're connecting to. I'm doing localhost and my database because my database is stored locally. But if you have an actual server, you can connect to that as well. So then it allows you to select different items you want to import. And if you select a few, you actually may be able to select the related tables, and anything where it's got a foreign key constraint, it's going to select those as well. So that's what I've done, and then I'm going to load that data up. So it's just going to show up in the sidebar like this, and it's going to go ahead and connect to the database and load the data up. And build any relationships that there are. Okay, so now I've got this course taken table. I might want to show it inside the actual sheet. So I've just specified that I wanted to create a table inside the sheet, and I've loaded that in, and that's all good. But now someone might be deleting data from my database or updating data. So let's say someone went and deleted one of the courses taken. So they're deleting where the ID is equal to 10, so there will no longer be a record for ID equals to 10 in the course taken table. If we go back to our Excel, we can refresh and we'll see that the ID of 10 has now disappeared because it's been refreshed to match what is in the actual database. You can also go ahead and do this edit, and it will open this Power Query editor. This lets you sort of manipulate what data is showing in the different tables if you wanted to remove certain columns or whatever. And it also allows you to sort of merge queries, which allows you to combine two different tables into one. So if I've got the course table, I might add the teacher table, and I can choose any type of join, and you should know what these are from my course previously: left outer, right outer, inner. And you specify which columns you want to join on by selecting them in the tables, and it will create that merged table for you. You can rename that to whatever that is. So this is the courses with the teachers. And then you can go ahead and edit these values here. So you can sort of expand them out and specify what you want. I'm going to select that I want to include all those. I might want to remove the course taken constraint. I might want to remove this ID column, but I'll keep the first name, last name, and email. I might want to remove this course as well. You can sort of just do whatever actions you want, and it's all kind of simple to use. And then you could do whatever you want to and manipulate the data however you want to in Excel. So this might be useful if you've got some existing sort of Excel processes that you use. Maybe you've got some macros that you want to run over the data, and you manually were pulling the data out previously and putting it into Excel, but maybe you want to automate that by connecting through to the SQL database. Now you know how to do that, and you can do that and run whatever Excel processes you'd normally run, and you should be all right there. Once you're happy with everything, then you can just go close and load. And you'll be able to see that new query is available right there. And it's got all the data that you've specified and worked with inside the Power Query editor. So that's about all I have for you today, and I really hope you've enjoyed this course. If you have, please like and subscribe for more content. And I'll be doing more advanced SQL courses in the future, but for now, this is it.